All right, folks, let's take a little looky-loo at periodic trends. What is a periodic trend? Well, periodic is referring to the periodic table, and a trend is something that happens as you go, up or down a group or across a period. Okay, remember the groups of the families on the periodic table, those are the things that are running up and down. Okay, so these little fellows right here, these are your groups. Okay, a period goes across the periodic table, so those are going to run horizontally. And so we know that there are trends which occur all over the periodic table. Okay, the first one we're going to talk about is the atomic size. Okay, atomic size is referring to the radius of an atom. Okay, so how large are atoms? So what I want to do is, let's see here. I want to pause real quick. Okay, so what I want to do real quick is I want to show you groups and periods. So here's a group right here, and then periods are going to move across the periodic table. So let's go ahead and see what atomic radius is going to do as we're moving along the periodic table. So this says atomic size decreases across a period and increases down a group. So what does that mean? That means that as I go across a period, it's going to get smaller. And as I decrease, it's going to get larger. So theoretically, the largest atomic radius should be francium. So what I can say is that as I move across the periodic table, as I move down towards francium, okay, my atomic radius is going to increase. As I move towards helium, my atomic radius should decrease. So theoretically, according to that periodic trend, helium should have the smallest atomic radius, and francium should have the largest. Okay, so that's the idea of that particular periodic trend. Let's take a look at ionization energy. Okay, first off, what is ionization energy? Okay, ionization energy is the energy that's required to remove one valence electron. Okay, remember, valence electrons are your outermost electrons. So if you're going to remove one of those, it takes some amount of energy for that to occur. Okay, now some atoms are going to readily allow you to take an electron, and some of them do not want you to take an electron at all. So this says that ionization energy increases across a period. So as you go across a period, the ionization energy is going to increase. As you move, it says ionization energy is going to decrease down a group. Okay, so as we go down a group, the ionization energy is going to decrease. So what that means is that the atom with the lowest ionization energy would be francium. Okay, francium's got electrons in its outermost energy level, and it says, you know what? I don't even want them. Take them. Okay, just it takes very little energy to take electrons away from francium. It has a low ionization energy, whereas helium would have a very high ionization energy. Okay, it does not want to give away its electrons, so it's going to take a lot of energy to remove an electron from helium. So let's take a look at one more periodic trend, and that's the periodic trend of electronegativity. Okay, what is electronegativity? It says this refers to the attraction of an atom it's the attraction that an atom has to gain an electron that may be around it. Okay, so how bad does an atom want an electron? So some atoms really want electrons really, really bad, and other electrons really don't want electrons. Now, we need to think about our noble gases for a moment. We're not going to include our noble gases in this situation because noble gases are inert. Okay, they have no electronegativity because they already have all of the electrons that they could ever want. Okay, so they don't have electronegativity because they don't need more electrons. So let's take a look at our periodic table, or actually let's stay here for just a second. It says this means that fluorine would theoretically have the highest electronegativity. Okay, so as I move towards fluorine, as I move across a period, the electronegativity is going to increase. As I move down a group, the electronegativity is going to decrease. So that means that as I move this direction, as I move towards fluorine, electronegativity is going to increase. As I move towards francium, electronegativity is going to decrease. So francium has almost no electronegativity. Okay, it does not want its electron. Okay, so if it doesn't want its own electron, it's not going to try to gain other electrons. So that, my friends, is the idea behind the electronegativity periodic trend. Question: are those the only periodic trends? Certainly not. Okay, certainly those are not the only periodic trends, but those are the ones that we are going to discuss. Have a great day.